Lesson 4 for Year 13 Physics, and this is on Lenz's law. So Lenz's law helps us to know the direction of the induced current, and this can be explained in two ways. We can use the law of conservation of energy that states that energy cannot be created nor destroyed, but only changed from one form to the other. So when a magnet is moved in and out of a solenoid, work has to be done to create an induced voltage and hence a current if the circuit is complete. So in the presence of changing flux, the direction of the induced voltage is such that the magnetic field the induced current creates opposes the change that produces it. So the induced current acts in such a way as to oppose the change in flux. For example, if the north pole is brought towards the solenoid, the induced current will flow in such a way as to repel the approaching north pole. So it will induce a north pole here, and so when you use your right hand grip rule, you can figure out what the direction of the current is. So why does a magnet drop slowly when falling through an aluminium rod? Now, aluminium is not magnetic. Okay, so when you have an ordinary piece of metal falling through an aluminium rod, gravity will act on it and it will fall down as expected. It will accelerate down. However, if you have a magnet that is falling through an aluminium rod, this falling magnet will induce a north pole below, because the aluminium rod kind of acts like a solenoid, and it's going to induce a current such that the direction of the current will try to stop the magnet from falling down. So there will be a north pole here, and over here it looks like it's a south pole leaving the solenoid over here. So that's going to induce a north pole there trying to pull this back up, and so you have the current flowing in opposite directions above and below the falling magnet.